Hi friends, welcome to my channel. In this video, we are going to discuss about joint probability, conditional probability as well as independent events. First of all, we are going to discuss about the joint probability. The joint probability is a statistical measurement where the calculation is get carried of probability of occurrence of two events together at the same point of time. We simply say that we are having two events named as A, B, and both these events are occur at the same time. Then we are going to be finding the probability of those two events. Let's consider here, if you observe over here, A and B both are occur at the same time, and the corresponding area is going to be mapped over here, and this is the portion where both A and B are get occur. Now we are going to be finding the corresponding probability. Let's consider the experiment we perform for n number of times. Out of these n number of times, our required event A, B together are get carried for n of AB number of times. Then the joint probability is formulated as P of A intersection B is equal to n of AB given n. So this is to be defined as the joint probability. Further, we go for an example over here. Here we consider we are having a box where two different resistors are get carried in the box as 1 kilo ohm resistor and 10 kilo ohm resistor with the respect to tolerance as 5% and the 10% tolerance as shown over here. Let's consider two events are get carried as event A describe about taking 10 kilo ohm resistor, and event B describe about taking 1 kilo ohm resistor, and event C describes about taking 10% tolerance resistors. Now we go for the joint probability of these events as probability of A intersection B, probability of B intersection C, probability of A intersection C. Let's go for the first one, probability of A intersection B, where A is nothing but the collecting the 10 kilo ohm resistor, and event B describes about the taking the 1 kilo ohm resistor. Now if you observe, both these event A and B are not having any common features. Why? Because these two A and B are different elements and there is no joint representation of these two. Under that condition, probability of A intersection B is going to be, we know, n of AB by total number of sample space is the n, and where there is no possibility of carrying the A, B common components. So under that condition, the n of AB is the 0 out of n is the total length of the sample space is the 55. So we get the value of probability of A intersection B is the 0. Similarly, we go for the second one, such as probability of B intersection C. Over here also we are going to write the n of BC by n. It means the number of components are carrying the mutual information of BC out of total number of the samples. We know the B is nothing but the 1 kilo ohm resistor, and C is nothing but the 10% tolerance resistor. And over here we are going to be represent the corresponding B and C component representation is get carried as, we know the B is nothing but the 1 kilo ohm resistor and C is the 10% tolerance resistor. So totally we are having the combination of 5 such resistors. So N of BC is the 5 out of 55 resistors. This is the second one. Come to the third one is the probability of A intersection C. Nothing but the number of components are the resistors. They are having the mutual information of AC out of total number of samples. So AC nothing but both the events taking the 10 kilo ohm resistor and 10% tolerance as how many? 25 such resistors are get carried over here. So 25 by 55. So in this fashion we are going to be finding the corresponding joint probability components. Now we move towards our second concept is the conditional probability, where the conditional probability is defined as likelihood of event or outcome occurring based on the occurrence of the previous event. Let's consider we are having a box. In this box there are 3 balls such as black, and the red, and another one is the yellow, and all these 3 are equally likely event. All these 3 are equally likely event. It means all these are having the same probability. Let's consider the probability of taking black ball. We know as per our representation as how many black balls are there? One black ball. Out of how many balls in total over here? The 3. So we get the probability as the 1 by 3. Now I am going to make sure that whatever this particular black ball that I have taken over here, I am not replacing the same in the box. It means it is having only the red ball and a yellow. Under such condition, if you are going to be finding the probability of the corresponding red ball is to be calculated as how many red balls you are having? 1 red ball. And what are the how many number of balls you are going to be having? Only 2 balls. That's why it is going to be the 1 by 2 over here. It means based on the condition, what the condition we are taking here, we are not replacing the black ball. Under that condition, the probability instead of the 1 by 3, the probability has get changed as the 1 by 2. So these type of representations are going to be get carried. Nothing but the occurrence of the one event is depending on the another event that previously get carried, and that type of representation are going to be discussed or carried by using the conditional probability. In order to carry this particular conditional probability, let's consider we are having 2 events A comma B are the 2 events, and these 2 events are going to be having the some mutual information, nothing but a joint probability. Under that condition only it is possible to carry out the conditional. Why? Because the occurrence of one event should be depending or affect the another event. It means they are going to be having some sort of the mutual information. It means A and B are having some amount of joint probability. Under such condition, we are going to be writing the probability of the occurrence of event A based on the event B. Nothing but probability of A given B is nothing but the number of events they are going to be get carrying both AB out of N of B. And in order to solve this one, we are just multiplying this one with the capital N and divide with the capital N. Then we are going to be having N of AB by N divided by N of B by capital N. So here if you observe, the numerator is going to be discussed about the probability of A intersection B by, and this is to be defined as the probability of the B. So together we are going to write probability of A in given B nothing but probability of A intersection B given or by probability of the B component. So this is the way that we are going to be calculating the conditional probability. And over here, if you go for probability of B given A is to be written in the form of probability of A intersection B by probability of A, where probability of A given B is not equal to the probability of B given A. Both are differ. Why? Because here in the first one, the oft means we are calculating the probability of A based on the B. Here we are calculating the probability of B based on the A values. So these two are not same. Now come to the independent events. The independent events are nothing but, let's consider we are having two events A comma B, and these two events are said to be independent, such as the probability of one event is not depending on the another event. Means these two are going to be far differ. They are not having any mutual correlation or coordination. Under that condition, we are going to be having the independent event. Nothing but probability of A given B, as we know, as per formula, probability of A intersection B by probability of B. But as we are saying that, and both these two are differ, under that condition, probability of A intersection B written in the form of probability of A into probability of B given probability of B. So we get the value as probability of A. It means the probability of A is purely independent of the B. That's why we are just finding the probability of A given B, where B is not having any relation with the A. Under that condition, we directly get the A of A. And with this, we are going to be stop over here, and we further proceed into the corresponding total probability and the Bayes theorem in the next lecture. Thank you. Thank you very much.